So this is the last video for chapter 14, and this talks about the pH and pOH scales, which are ways to express acidity and basicity. Starting with the pH scale is a way to quantify acidity and basicity, and the formula is pH is equal to negative log of the concentration of H3O plus. Sometimes we can see the formula written this way: pH is equal negative log of H plus. And again, this and this formula and this formula are the same because hydronium ion is the same as the H plus. If you look at the scale, any solution that has a pH of 7 is going to be a neutral solution. Any solution with a pH that is lower than 7 is going to be an acidic solution. And if you notice that as you go away from the 7, the acidity increases. So a solution with a pH of 1 is much stronger than a solution with a pH of 5, for example. And when the pH is higher than 7, then the solution is basic. And again, as you get away from the 7, the basicity increases, and a solution with a pH of 13 is much stronger base than a solution of a pH of 9. So here are some common ways to measure the pH. We have the pH meter, which technically gives you a number of the pH of the solution. We have the pH paper, and we call it litmus paper, and this paper changes color whether you put it in acidic or a basic solution. Also, there is the degree at which the color changes. It tells you the degree of the pH or the value for the pH. And another way is these indicators, and some indicators will have different colors whether the solution is acidic or basic. And we kind of saw the indicators before when we talked about titration. So this here shows you some common substances and their pHs. For example, your gastric acid is 1.6 pH, lemon juice is 2.2, vinegar 2.8. If we look at something like potatoes, it's 5.8. Water, pure water is 7. Drinking water is slightly basic, it's 7.2. Your blood plasma is 7.4, so it's slightly basic. Seawater is 8.5, bleach is 12, NaOH is 14. So these are some common substances with their pH. Now, how to count significant figures in the case of pH. So remember, pH is a log scale. So when I take the negative log of this number and I get 2.00, the number that are to the left of the decimal point actually corresponds to the 10 power. And then the number that are after the decimal point, this is what comes from the coefficient in that scientific notation number. Therefore, when I count the significant figures for the pH, I only start counting the numbers that are after the decimal point. Since my concentration had 2 significant figures, then I have to report 2 decimal points to convey 2 significant figures. So it's not, I'm not gonna write 2.0 because this would be only 1 sig fig. It's gonna be 2.00. So again, the numbers that are to the left of the decimal point, these are coming from the power, and they are not counted when we count significant figures. Now, what is pOH and pKW? So remember, when we talked about the pH, we took the negative log of the concentration of H3O plus. So the P itself means to take the negative log of a value. So when I talk about pOH, then it's going to be the negative log of the concentration of OH minus. When I talk about the pKW, is equal to the negative log of kW. Remember, kW is 1.0 times 10 to negative 14. So pKw is simply 14. And there is a relation between pH and pOH. So pH plus pOH is equal to 14. You guys are responsible to memorize all of these. So you are responsible to memorize pH, you are responsible to memorize pOH, and you are responsible to memorize pH plus pOH is equal to 14. Now, how can we do the calculation? So here in this example, we are going to calculate pH from the concentration of either H3O plus or OH minus. So let's work the first one. So first of all, the question is calculate the pH of each solution at 25 degrees Celsius and indicate whether this solution is basic or acidic. So starting with the A, concentration of the H3O plus is 1.8 times 10 to the negative 4. So to calculate the pH, we simply gonna use this equation. pH is equal to negative log of the concentration of H3O plus. Then we just substitute the numbers for the concentration, and we get a pH of 3.74. Now the pH does not have a unit because it's a log scale, so it doesn't have any units. Now to determine the if it's acidic or basic, I'm gonna compare it to the pH of 7. So pH is lower than 7, and this is why the solution is acidic. Now the second example, OH minus. So in this case, I can calculate a pOH, and the pOH is equal to negative log of OH minus. And again, I just substitute this number in the equation, and I get pOH is negative log of 1.3 times 10 to the negative 2, which is equal to 1.89. Now remember, I am asked to find pH and not pOH. So for me to be able to find the pH, I'm going to use this relation. pH plus pOH is equal 14. So I have to solve for pH, and that would be pH is equal to 14 minus pOH. So it's 14 minus 1.89, and the pH is equal to 12.11. So any solution with a pH higher than 7, it will be a basic solution. Now here we're gonna use a pH to calculate the concentration of H3O plus. So it's the opposite. Instead of giving us the concentration and us calculating the pH, here we will be given the pH and we need to calculate the concentration of H3O plus. So again, I'm starting with this equation. pH is equal to negative log of H3O plus. In this case, my given is the pH, so I have to solve for the concentration of H3O plus. So first thing I'm going to do, I'm going to move the negative sign to this side, to the pH. And then to solve for the concentration of H3O plus, I have to take the 10 power for both sides. And then once I take the 10 power for both sides, this stays 10 to negative pH, but this one, 10 to the log of the concentration of H3O plus, will simply become a concentration of H3O plus. So then the relation would be concentration of H3O plus is equal to 10 to negative pH. If you don't know how to manipulate these types of equations, you simply have to memorize this equation. So you have to memorize that H3O plus concentration is equal to 10 to negative pH. And if I was talking about OH minus concentration, so that would be OH minus is equal 10 to negative pOH. So again, if you don't know how to manipulate algebraically manipulate the log function, you have to memorize these relations. So you have to memorize that the concentration of OH minus is equal 10 to the negative pOH, and the concentration of H3O plus is equal 10 to the negative pH. So going back to our example, to calculate this, all I need to do is to substitute the pH with the 4.8. So then I get 10, so the concentration of H3O plus is equal to 10 to negative 4.8. So you have to put this number into your calculator, and then the calculator will give you 1.5 times 10 to negative 5 molar. So again, so there is a bunch of equations to memorize for this. You have to memorize the equation for pH. You have to memorize the equation for pOH. You have to memorize the relation that tells you that pH plus pOH is equal to 14. if you don't know how to manipulate this algebraically, you have to memorize the concentration of HGO plus is equal to 10 to negative pH, and the concentration of OH minus is equal to 10 to the negative pOH. So all of these are to be memorized. And with this slide, we conclude chapter 14. And later, I will actually email you a GLA, which is a practice for chapter 14. And see you all on